Hello, good morning everyone. My name is Patrick Doe, and I'm a technical trainer at AWS. Welcome to AWSome Day Online Conference. Today, I'm going to cover the fundamental concepts and services that AWS offers and architectural best practices. I'll be later joined by my colleague Sander, which will talk about AWS security, pricing, and support. All right, enough of introductions, let's jump in. What are the core goals, and what are we going to cover today? The concept of the cloud, or value proposition of why organizations are moving to and using the cloud. What the cloud is. It's not a magical place in the sky that you run infrastructure. The cloud is still data centers and infrastructure that we've all known and has been around. The difference is that instead of building and maintaining this resource, cloud providers like AWS maintain and provide these resources as a service. We will go through a variety of key services, best practices with security and architecture design, and then finally wrap up with how pricing works in AWS and support. The course will be broken up into 5 different modules, starting off quite high level, and we'll dive deeper into technologies as we go throughout the day, and go back out towards the end with pricing and support. Module 1, Introduction to the AWS Cloud. What is the AWS Cloud? Before we talk about the AWS Cloud, first let's define what is the cloud. I like this question. What is the cloud? Because there are so many different definitions today, depending on the context of who's listening. If it's friends or family, when we think cloud services like online storage, content streaming, and online applications. For businesses, cloud services could be platforms and infrastructure as a service such as databases and virtual servers. Cloud services are products or offerings in which their primary delivery channel is over the internet. But today, let's focus on AWS Cloud. What is the cloud in the perspective of AWS? We consider ourselves a cloud service provider. The idea is that we provide IT resources and applications over the internet. These resources are nothing new or different. They're the same on-premise servers and data centers we've had for decades. The main difference is, as a service provider, you don't have to deal with the ongoing maintenance and management of these resources. We provide everything you would need in a traditional environment to build your applications and services such as servers or compute, storage, databases, and applications. So how does it all work? The idea is that we maintain and manage the infrastructure required to provide core IT resources like compute, storage, networking, and databases, and we provide it to you as a service available over the internet. As a large provider, we have vast amount of resources, so you just provision what you need when you need it, and only pay for what you use. Today, a lot of customers are using the AWS Cloud to build and deploy their IT services and applications. When it comes to cloud deployment models, they typically fall into one of 3 categories. On-premise, or known as private cloud, in which customers build, run, and maintain a cloud environment in their own data centers. Hybrid cloud, in which they augment the capacity of their existing data centers by utilizing a public cloud provider like AWS, common against enterprises with legacy systems. Finally, all in the cloud, in which they wholly run their IT services and applications on the cloud, which is very popular among startups today. So, what are some of the benefits of the cloud? Why are people moving to the cloud, and how does that change the way we build and deploy IT services and applications to our customers? The first is trade capital expense for variable expense. Traditionally, to build or develop a new service requires infrastructure planning to build servers and data centers to provide these services. This process involves capacity planning, procurement, and construction of these data centers. This process would be timely and costly and pose a lot of risks and resources that may or may not be of value for an unproven service or product, in which resources could be better diverted to new projects elsewhere. The cloud allows us to reduce this risk and only pay or invest in capital on resources when we use it, or pay only for the amount you consume. Massive economies of scale. AWS is a large cloud provider, right, and offers services to hundreds of thousands of customers. Because of this scale, we can find efficiencies, which translates to lower prices for you, our customer. In fact, AWS has reduced prices 72 times since our launch in 2006. My favorite is when AWS reduced the pricing of S3 in half in 2016. If you search pricing reductions on AWS, you'll find about these. Stop guessing capacity. The corollary to trade capital expense for variable expense is that when we try to build services and size our data center, we build it based on the forecasting models and prediction of usage, which typically leads to one of two scenarios. What if we build more capacity than we need? Well, this would lead to wasted resources in which we have servers and compute idling and underutilized, which could be capital we could invest in new initiatives or projects, or people to help grow our business. The other scenario, what if we build less capacity than we need? Well, this would lead to not enough capacity to serve our customers, impacting the services we provide, leading to customer attrition or lost opportunities. Neither scenario is good. It's a lose-lose situation. We're trying to predict the future. That's very hard to get right. With AWS Cloud, we can provision just the capacity that we need. If we need more, we can get more. If we have too much, we can get rid of it. No more issues with limited capacity or excess spend. Increased speed and agility. How long does it take for you to get resources today? Does it take minutes, hours, days, or weeks? I remember working at a storage company as an intern in the R&D team back in 2014. My task was to build and forecast the next 5 years. I was required to analyze a large data set, about 5 gigabytes at the time, and it needed a database server to process this. I remember putting in my request on the very first day of the internship, and while I was running my queries on my local laptop, 3 months go by and my internship wraps up and I send in my report. While checking out, I finally get an email from IT that my database server was finally ready. Does this sound familiar? Today, in the AWS Cloud, you can get resources within minutes, allowing your developers and engineers to get started quickly, ultimately increasing your agility in which your organization can experiment and try new ideas, bringing innovation back into your organization. Stop spending money on running and maintaining data centers. I've already talked about this before, but look at it from a different perspective as businesses. Do any of us run a business in which our primary product is IT services and applications? Most likely not. And even so, is your business providing the core resources like servers, networking, and storage? You're probably providing some other service utilizing these resources. Every modern business today needs IT resources and services to function. Why are you wasting time and money on these tasks that don't help you focus on your core business? Let someone else deal with it instead so you can focus on what matters. Go global in minutes. AWS, being a global cloud provider, has infrastructure built around the world. This means that you can leverage these resources whenever you wish, making it easy to expand and optimize your services for customers around the world. We'll talk more about AWS infrastructure in the next module. At AWS, security is a top priority. From the design of our data centers to our services, we start from the ground up with security in mind as a focus. We put strong safeguards through tools and practices to help protect the data you store. When you build our services, we work with regulators to ensure we meet compliance requirements so that you can start off on a stronger foundation. Ultimately, allowing your business to focus on what matters, saving money, and giving you the capacity to scale when needed. So what is AWS Cloud? Today, the AWS Cloud is an on-demand offering of IT services and resources available over the internet in a pay-as-you-go model. From infrastructure services such as compute, storage, and networking, platform services like databases, AI/ML, and automation tools, to application services that make it easy to manage documents, email, and virtual desktops in the cloud. Today, AWS provides over 140 services you can leverage to build your business, all of which have been driven by valuable feedback we get from you, our customer. So don't be afraid to let us know how we can do things better or if there's something you need. AWS Global Infrastructure. We talked about how AWS builds and manages data centers around the world for you. We organize these data centers into what we call regions, availability zones, and edge locations. It's very important to know these concepts as they are vital to building highly available and fault-tolerant systems on AWS. What does this look like? This is AWS. Let's flatten it to see how it's all put together. Here, you can see AWS's data center organized around the globe into our regions, which are in orange, availability zones, which I'll show in a little bit, in blue, and edge locations or points of presence in pink. It's important to know these concepts because they're vital to building highly available and fault-tolerant systems on AWS. Let's take a closer look at one of the regions. In this case, Singapore, or AP Southeast-1. A region is where we serve our services such as Amazon EC2, Amazon S3, etc. They are designed to be completely isolated from the other regions, meaning that when you create resources in AWS, they'll be tied to the region you select and don't replicate automatically. In the next slide, we'll talk about how we differentiate the availability zones, or AZs. Every region around the world is comprised of 2 or more availability zones, also referred to as an AZ. These AZs are comprised of 1 or more data centers, meaning there may be multiple data centers in a single region. So how do we separate these data centers into AZs? When we design a region, we have to take into account what hazards or scenarios can take down a physical data center, such as utility faults, such as power and network outages, but also geographic hazards like typhoons, floods, and earthquakes. Or my personal favorite, a supersized T-Rex coming from the depths of the ocean and destroying an availability zone. However, they are still close enough for low latency replication. For example, here we have AP Southeast 1, also known as Singapore, which is comprised of 3 availability zones, denoted with the suffix A, B, and C at the end of the identifier AP-Southeast-1. For some resources, like an Amazon EC2 instance or a virtual machine in the cloud, we create these in availability zones, meaning that if that supersized T-Rex woke up today and stepped on a particular availability zone, it would destroy our EC2 instance. So we have to architect or deal with this by having 2 EC2 instances instead of 1. However, availability zones don't deal with what I consider calamities or catastrophic events, such as a comet strike hitting the Earth. But in all honesty, if a comet hits the Earth, it's also worth considering what business priorities are at that point. Do I really need to have my online delivery business available in an incident like a comet hitting the Earth? In which we have tools and options to replicate across regions, which we talk about later. So, what are some things you need to consider when selecting a region? First is data governance and legal requirements. Does your workload require you to keep your data sovereign in your borders? If so, this is the first criteria. Second is latency. The closer the region is to your customers, the faster you can provide those services to them. I got a case once, which a customer complained about speeds to AWS S3 for a data analytics workload. They had terabytes of data sitting in S3, our object storage service in North Virginia, one of our regions. That was taking hours to load into their Redshift cluster, our data warehouse service. With further investigation, we found that their data warehouse was sitting in Tokyo, meaning that the data had to travel the World Wide Web from the US to Japan. So don't forget your internal customers as well. Service availability also varies from region to region as well, as more mature regions will have newer services over the newer regions. If there's a service you desire in a region, please submit feedback to AWS so we know to bring it to your region. Finally, cost. Land, power, and hardware do not cost the same around the world, so some regions will be cheaper than others. The last concept about AWS infrastructure is edge locations, also known as points of presence. These are mainly used for lowering latency to access AWS resources using a global network of 166 locations around the world. Some services that take advantage of edge locations are Route 53, our DNS service, and CloudFront, our content delivery network. Management interfaces. So how do I access AWS to create these resources? There are 3 main ways to interact with AWS. The first is the AWS Management Console, which is an easy-to-use graphic interface available on the web or as a mobile app. The second, the command line interface, or CLI, that you can download and install, is available on Windows, Linux, and Unix systems. And finally, the software development kit, or SDKs, that you can import into your code, available today for popular languages. Behind the scenes, all these interfaces are just talking to AWS over the internet via an application programming interface, or API, which is also available to use. In review, AWS provides on-demand IT resources and services such as compute, storage, databases, and more over the internet in a pay-as-you-go model. AWS builds and manages the infrastructure or the data centers and networks around the world, organized into regions, availability zones, and edge locations you can leverage to host your services. Finally, as long as you have access to the internet, you have access to 3 choices to interact with AWS via the AWS Management Console, CLIs, and SDK.